In the heart of a bustling Mac OS environment, a pipeline emerged from the fires of the forge, running relentlessly for 40 days and nights without a single manual intervention. This is not a tale of desire, but a testament to the fruits of labor. 3 Python-driven YouTube channels humming along in perfect synchronization. The system we forged was built around the native power of Python on Mac OS, wielding its strength to automate content pipelines without resorting to external plugins or extensions. The crux of our strategy lies in careful scrutiny. Before integrating any third-party tool, we verify its unique capabilities that surpass what can be achieved with native Claude code. In the realm of production systems, this approach is paramount. It avoids unnecessary complications and potential conflicts that may arise from third-party tools. Some tools, like OpenWolf and Graphify, write to /Claude/, leaving behind residue that can cause chaos in the forge. Another pitfall to avoid are security tools with kernel extensions, such as Malwarebytes. Even when deleted via Finder Trash, these tools persist, requiring the use of their official uninstallers to vanquish them completely. If a tool's daemon proves resilient against the official uninstaller, take decisive action, reboot into safe mode, or employ the vendor's dedicated removal script. Here lies the path to forging robust systems on Mac OS with Python. We will delve deeper into each step, unveiling the precise methods used to build this automation powerhouse. Stay tuned as we continue to shape the future of your workflows, one system at a time. Chapter: The problem in the heart of a production system, where precision and efficiency are paramount. An issue persists: the haphazard installation of plugins, wrappers, and third-party Claude extensions. This problem, once left unchecked, can lead to tangled codebases, increased vulnerabilities, and a steep time investment in cleanup efforts. Consider a system where an average developer spends 10 hours per week managing these additional tools. At $80 an hour, that's $4,000 a month wasted on maintenance that could have been spent on productive work. This is not a theoretical scenario, but a reality faced by many developers working with Mac OS and Python. The common solution of indiscriminately installing these tools has proven to be flawed: the failure mode. Tools that write to /Claude/, such as OpenWolf or Graphify, often leave behind traces, creating a cluttered environment that can lead to conflicts and instability. Security tools with kernel extensions like Malwarebytes also pose a risk. Even after deleting the app via Finder, they persist in the system, lurking beneath the surface. The viewer, who may have already fallen into this trap, now seeks a solution. The broken method of relying on third-party tools without careful consideration has failed them, leaving their system tangled and vulnerable. It is time to forge a new path. In the next chapter, we will discuss the rules going forward, crafting a system that is secure, efficient, and free from unnecessary complications. Chapter: The materials in the crucible of the Mac OS development landscape. We forge our tools with precision and purpose. The following components, carefully selected from the anvil of countless possibilities, form the foundation of our Python plus Mac OS stack. 1. Python version 3.9.7, available via homebrew or direct download from Python.org. With its extensive library ecosystem and versatility in system scripting, it's the backbone of our forge. The alternative, Python 2, while still supported by some projects, has reached its end of life, making Python 3 the clear choice for future-proofing. 2. homebrew version 3.5.7, a package manager for Mac OS. It simplifies the installation and management of software packages, saving us valuable time and effort. The alternative, MacPorts, offers similar functionality but has a larger footprint and slower update cycle. 3. pip the Python package installer, bundled with Python 3.9.7. It enables the download and installation of third-party Python packages from PyPI, the Python package index. Alternatives like Conda offer more comprehensive package management but introduce additional dependencies and complexity. 4. Jupyter Notebook version 6.1.5, available via Homebrew or pip. This interactive computing environment allows for easy-to-follow documentation and live code execution, enhancing the development process. The alternative, RStudio for R, offers similar functionality but lacks the widespread adoption and integration with other tools in our stack. 5. VS Code version 1.56.2, available via Homebrew or direct download from Visual Studio.com. This versatile code editor integrates seamlessly with Python, Jupyter Notebook, and Homebrew, providing an efficient workflow without the hefty cost of high-end IDEs like PyCharm. Each component in our stack has been chosen for its balance of functionality, ease of use, and minimal impact on system performance. However, it's essential to understand that no tool is perfect, and each alternative offers unique advantages. The key is to forge a workflow that maximizes productivity while minimizing risk and complexity. Chapter: The Build in the Crucible of the Forge. We shape Python on macOS to serve in the realm of Claude. Today, we mend a system that was fractured by the installation of unnecessary tools, illuminating the path forward for those who seek to refine their craft without compromise. First, we must purge the intrusions that have disrupted our equilibrium. Let's examine the landscape. 1. Purging the intruders sh sudo find // Claude type dname open wolf exec rm ref / sudo find // Claude type dname graphify exec rm ref / These commands sweep through our system, seeking out and vanquishing the rogue tools, open wolf and graphify, from their hiding places within // Claude. Let's examine the landscape. 1. Their destructive tendencies are a danger we cannot afford in a production environment. 2. Assessing the damage sh/ls Claude / By examining the contents of our forge, we verify that these intruders have indeed been expelled. 3. Strengthening our defenses we fortify our system with a new rule. Before installing any plugin, wrapper, or third-party Claude extension, ensure it offers capabilities beyond the reach of native Claude code. If the benefits are unclear, refrain from installation. 4. Mending the wounds to mend the fractures caused by other tools. We must be vigilant and precise in our approach. A. Uninstall Malwarebytes. sh sudo mwbtune installer u. This command invokes the official uninstaller for Malwarebytes, dismantling its kernel extension. If the benefits are unclear, refrain from installation. 4. B. Reboot into safe mode. sh shutdown hnow s. Upon reboot, we enter safe mode to ensure that any residual traces of Malwarebytes are eradicated. 5. Verifying our success we once more assess the health of our system. A. Reboot and check for Malwarebytes presence. sh launch list grep qcom, Palo Alto Networks, Malwarebytes echo $. If the exit status is 1, Malwarebytes has been successfully removed. B. Examine // Claude for any lingering intruders. sh/ls // Claude / If no foreign entities remain, our system is restored to balance and harmony. In this chapter, we have forged a stronger, more resilient Python environment on macOS for Claude. By adhering to these rules, we ensure that our system remains clean, efficient, and ready for the challenges ahead. Chapter: Deep Dive in the Crucible of a Real Production System. The forging of a robust and efficient workflow is no trivial matter. The breaking point arrived when the rules governing the integration of third-party components into macOS and Python needed reevaluation. The foundation of our forge lies in native Claude code, a versatile construct that serves as the backbone of our system. It's crucial to understand that adding unnecessary plugins, wrappers, or third-party extensions could potentially weaken this structure, leading to instability and increased complexity. Before introducing such elements, scrutinize their potential to offer significant capabilities unattainable with native Claude code. If the benefits are unclear, refrain from installation. The danger lurking in tools writing to // Claude / OpenWolf, Graphify et al. Is palpable. These high-risk artifacts often leave behind residue during cleanup, leading to potential conflicts and system instability. Security tools with kernel extensions, Malwarebytes, etc. present another challenge. Even after deletion via Finder Trash, these elements persist within the system's core. To ensure a complete removal, always utilize the official uninstaller provided by the vendor. If the daemon of a security tool remains post-uninstallation, resort to booting into safe mode or employing the vendor's dedicated removal script. In the forge of Mac OS and Python, every component must serve a purpose. Adherence to these principles ensures a strong, stable structure that withstands the heat of production. By understanding the why behind each rule and avoiding common pitfalls, we shape our system into a refined, efficient instrument of our craft. Chapter: Stress Test the Forge Blazes. as the system undergoes its pivotal stress test, a crucible of real-world performance and edge conditions. The furnace roars, pushing the Python plus Mac OS amalgamation to its limits, revealing weaknesses that must be hammered into strength. The first blow struck was against the rules, going forward a set of guidelines designed to streamline the forging process. As the system strained under load, these rules buckled under the pressure. It became apparent that third-party plugins, wrappers, and extensions could pose a threat, their intentions often unclear. A decision was made. Before incorporating any such additions, their necessity must be established beyond doubt. If they claim to offer significant capabilities that cannot be achieved with native Claude code, only then would they find a place within the Forge. Ambiguity is not welcome in the Crucible. Clarity and purpose are essential. The consequences of this decision were profound. A real production system was at stake. No cleanup on a demo machine, no second chances. The Forge master had to navigate carefully, ensuring each step was deliberate and informed. Another lesson emerged regarding third-party tools that wrote to /Claude/. These high-risk tools, such as OpenWolf and Graphify, often left behind residue in their wake. Their cleanup was rarely thorough, posing potential threats down the line. Security tools with kernel extensions, like Malwarebytes, also proved problematic. Even after deletion via Finder Trash, they persisted, lurking beneath the surface. To ensure complete removal, the official uninstaller must always be used, never relying on simplistic methods. The most challenging adversary, however, was the tenacious demon of a security tool that survived even the official uninstaller. In such cases, the Forge master would reboot into safe mode, or employ the vendor's dedicated removal script to expel the unwanted intruder. In the realm of the Forge, stress testing is not a luxury, but a necessity. A system that hasn't been stress tested remains soft and malleable, yet to be hardened by fire and pressure. The Forge master must remain vigilant, forging systems with precision, resilience, and an unwavering commitment to excellence. Chapter: The output. In this production system, we've fortified our Mac OS environment by establishing clear guidelines for integrating third-party tools with Python and Claude code. This has resulted in a significant reduction of potential vulnerabilities and streamlined our workflow. Firstly, we've adopted a rigorous policy. Before installing any plugin, wrapper, or third-party extension, we verify that it offers substantial capabilities beyond what can be achieved using native Claude code. If the utility remains ambiguous, we refrain from installation. Secondly, we've identified tools like OpenWolf, Graphify, and their ilk that write to /Claude/ as high risk. Their cleanup is often incomplete, potentially causing system instability or data corruption over time. We tread carefully with such applications. Thirdly, we've taken special precautions with security tools boasting kernel extensions, Malwarebytes, etc. These components survive app deletion, posing a threat to our system's integrity. To mitigate this, we always use the official uninstaller and avoid relying on Finder Trash for removal. Lastly, if a security tool's daemon persists even after using the official uninstaller, we take additional measures. We either reboot into safe mode or employ the vendor's dedicated removal script to ensure complete eradication. By adhering to these rules, we've successfully eliminated potential costs associated with system cleanup and saved valuable time in our production process. Our Mac OS environment now stands fortified against external intrusions, ensuring a stable and efficient workflow for Claude code development. In the Forge of your Mac OS, apprentice, a lesson learned. Before welding third-party Claude extensions, ensure they yield significant capabilities beyond native code. Uncertainty begets risk, and we strive for precision in our production system. Third-party tools writing to /Claude/ carry high peril, their cleanup often incomplete. Security tools with kernel extensions survive app deletion, thus requiring the official uninstaller, never Finder's Trash. If a daemon lingers, reboot into safe mode or employ the vendor's dedicated removal script. Now, forge ahead with this wisdom and let the fires of progress temper your craft.